My name is Bill, and thank you for watching this tutorial on how to fly from Jupiter's moon Europa to its moon Io in 28 minutes. I'm going to open mission scenery, then take rescue mission to Io. I'm not going to perform the complete mission. I'm just looking for how to fly to Io and to learn about orbital mechanics along the way. I will be estimating what I need to do to reach Io based on a fundamental understanding of orbital mechanics. We begin on the surface of Europa. It's night. We're facing 348 degrees, nearly north. We are near the equator and will have to fly east. We begin by using our hover rockets to get off the ground. We then yaw to the right until we reach 90 degrees. We will increase main engine thrust to maximum and pitch up. We will continue this acceleration until we establish an apoapsis of about 1,000 kilometers. I have no mathematical or scientific reason for choosing 1,000 kilometers. It's simply an arbitrary choice on my part. My intention was to reach a high enough altitude to make escape velocity easier. Once we reach our apoapsis, we will accelerate forward until we reach escape velocity. Upon reaching escape velocity, Europa is still the dominant source of gravity. We'll wait until we coast far enough from Europa so that Jupiter is the dominant source of gravity. Then we will reference Jupiter in the orbital MFD on the left and orient our ship to retrograde relative to our orbit around Jupiter. Now we've already done part of our work in flying to Io. By escaping Europa's gravity in the retrograde direction, we now have a periapsis that is not only smaller than Europa's orbit, but is closer to the mean orbit of Io. We will now fire our engines retrograde and further decrease our periapsis. Io has a mean orbital altitude of about 352,000 kilometers. Our target periapsis will be about 26,000 kilometers less, or 326,000 kilometers. Since Io's orbit is currently smaller than ours, it will pull ahead of us. Once we reach our periapsis, we will again do a retrograde main engine burn to circularize our orbit. With our final orbit smaller than Io's, we will gradually catch up to Io. The way I'm doing this will no doubt take longer than a formally designed trajectory. In this case, we will need to complete more than 3 orbits before catching up to Io. Now that our true longitude is about 2.65 degrees behind Io, we will do a prograde main engine burn to increase our apoapsis to reach Io. This will bring us to about 6,630 kilometers from Io. At this point, we see that our MFD shows that we are in a highly eccentric orbit around Io. This is not a stable orbit. At this point, we need to change our velocity relative to Io so that we can enter its orbit. Because of the power of Jupiter's gravity, An elliptical orbit is not recommended. Notice we have more than 61% fuel remaining. Compared with many of my attempts to reach Io, this is a very good outcome. I hope you enjoyed this tutorial. Please leave your comments below and share with all of us how a better trajectory can be designed and carried out. Thank you.